Saab began a series of studies for a replacement of the Saab 35 Draken on May 1952, which finally resulted on 1961 with Saab proposing to the Royal Swedish Air Force the Study 1563, which was later to become the Saab 37 Viggen. The first of 7 prototypes flew on February 1967. The test program was long and protracted. The first production aircraft flew on November 1977, and the Viggen entered Swedish service on June 1980. The last production aircraft was delivered on June 1990, with a total of 329 produced. The final Viggen was retired from service on June 2007. Four Viggen variants were initially built. AJ37, attack-jacked, was primarily an attack aircraft. 108 were built. SF-37, dedicated photo recce aircraft, with 7 vertical and oblique cameras on the nose, instead of a radar, 28 built. SK-37, 2-seat training variant, only 17 were built. SH-37, coastal recce variant, with a longer-range radar optimized for maritime operation, 27 built. The development of the much-modified JA-37 interception variant started on 1968, and its prototype flew on June 1974. It entered service with the F-13 wing on June 1980, and 149 were built. The delays with the Saab 39 Gripen program forced the need for a life extension program for the Viggen, which was ordered on 1991. Starting on 1993, 115 Viggens of the AJ, SF and SH variants were converted to AJS standard, equipped with an improved computer that allowed the use of some weapons designed for the Gripen, like the RBS-15 anti-ship missile, and the BK-90 standoff cluster munitions dispenser. This modernized AJS37 is the Viggen variant that is simulated on DCS by heat blur. Press spacebar to begin. It is a bit dark at this hour. If you can't find a cockpit element, feel free to employ your flashlight, which can be toggled with left Alt+L. Press spacebar to continue. We will learn an abbreviated cold start procedure for the Viggen, using just its own battery power and omitting all checks that are not really needed for DCS. Parking brake, set to on. The wheel brakes can be locked by depressing and holding the brake pedals, then pulling the parking brake handle. The brakes are released by depressing the brake pedals again. Unfortunately, if you employ hardware rudder pedals fitted with 2 separate toe brake axes, there is a simulation bug that forces you to release them perfectly in sync, or else the parking brake will release. As a workaround, to park the aircraft, operate both brake pedals by pressing and holding the W key on your keyboard, instead of using your rudder pedals. Press spacebar to continue. Data cartridge. Insert the mission's data cartridge onto a transfer slot on the rear left cockpit wall. The simulated action for this insertion is simply to mouse-click on the slot. Do it now. There are actually several data cartridges available to you, the default being the one with a flight plan created on the DCS mission editor, but there may be also cartridges with auto-generated plans to attack detected enemy groups, or you can even generate one based on marker labels that you place on the F-10 map. You can select the cartridge on the ground crew settings page of the kneeboard. Cycle through the available cartridges with left control plus left alt plus C. We will learn more about this on a future training mission. Main electric power, Huvudstrom, set to on, till. When cold starting with battery power, only the equipment connected to the battery buses and the main DC bus are powered. Please note that the battery endurance is about 15 minutes, so you need to perform the next steps quickly, until the engine is started. If you take too long and the battery dies when starting the engine, then call the ground crew by pressing \, and ask them to connect ground electric power. Once with power, reattempt the engine start and the mission should resume. The master warning and the red LT cron lights should illuminate. On the left warning panel, these lights will be on. 3 yellow lights, indicating low fuel pressure. 3 green lights, indicating the landing gear is down and locked. 2 red lights, for low hydraulic pressure, a red for low oil pressure, and the red electrical failure light. On the right warning panel, the following yellow lights will illuminate: radar altimeter failure, computer error, ejection seat and canopy status, fuel regulator is in manual mode, and oxygen valve is closed. Press spacebar to continue. Low pressure fuel valve, LT cron. Set to on, till. This switch opens the low-pressure fuel valve, which allows fuel flow to the engine. The switch also powers up the fuel feeder pumps. When the valve is open, the red light near the switch goes off. Master warning, press the black button to acknowledge the warnings. Cockpit illumination, set as desired. Each front panel instrument has integral lights, their brightness is adjusted with the highlighted knob. Panel lights. Both side consoles have integral lighting for its labels and readouts, their brightness is adjusted with the panel bell knob. Flood lights. 3 floodlights, 1 under the left and 2 on throttle, set to ground idle. Click the highlighted throttle catch. This action moves the throttle lever to its ground idle position, and also opens the high-pressure fuel valve. Good, this simulates the pilot advancing the throttle to its first catch detent, corresponding to its ground idle position. The throttle has 2 catch positions, ground idle and military power, plus 4 indents, 1 at flight idle and 3 at each afterburner stage. The afterburner has 3 distinct zones, 1, 2, and 3. The chosen afterburner zone is indicated on the right side of the instrument panel. The nozzle indicator shows the position of the engine nozzle, as well as the current afterburner zone. Press spacebar to continue. Check warning panel lights. Press and hold the warning panel lights test button. The master warning indicator, the alarm sound, and all the lamps on the 2 warning panels should illuminate. Additionally, the following lights are tested via the same button. Low pressure fuel valve warning light, LT cron. Thrust reverser indicator light. Autopilot indicator lights. Stability augmentation, attitude hold, and altitude hold. Auto throttle on, red indicator light, and AFK mode 3 white indicator light, alpha 15.5 degrees. Thrust reverser, reduced transonic indicator light. Stores released indicator light, falled last, not simulated yet. Afterburner 1, 2, 3, indicator lights. This is the last item, you can release the button now. Generator, set to on, till. Set the switch to its left position, to have it connect to the AC bus as soon as the engine attains enough RPM. FR24 radio, confirm it's set to normal plus guard. We will not be using this backup radio today, so set its mode to norm plus alarm, as this allows the FR22 to be the main radio. Press spacebar to continue. Radar panel, set initial radar settings. The PS-37A radar is a ground mapping radar, closely integrated with the navigation suite. The radar also has a ranging mode, to increase the accuracy of weapons delivery. Radar mode selector, set to its A0 position, radar off. It's a 3-position switch on top of the radar control stick, used to toggle between wide and narrow search mode. Press spacebar to continue. Anti-jamming, AS, filter mode selector, turn knob to position 1. Toggles anti-jamming filters. With the filters, it might become possible to determine the distance to a jamming target, and then perform a successful target fix. Passive search, set to off, Fran. When in passive mode, the radar will receive active jamming signals and display the direction from where they are received, but will not emit anything itself. Press spacebar to continue. Radar processing mode switch, set to log. On logarithmic mode, the terrain contacts are more nuanced and different terrain types can be discerned. Linear is a high contrast mode, useful for terrain avoidance or air-to-air combat. Radar antenna elevation dial, set to its middle position. The antenna elevation can be adjusted ±10 degrees from the set angle, by use of this dial. Press spacebar to continue. FR22 radio, set correct base and channel. The Viggen's primary radio, the FR22 is a combined VHF-UHF radio, which can be manually tuned, or employ one of 844 preset channels. To learn which the preset for Creech Airbase is, press right Shift plus K to open the kneeboard, then page forward until the Airbases page, which lists the radio frequencies of every airbase on the map. Use right Shift plus page up, or page down, to browse the full Airbases list. To select the proper preset, first turn the base selector dial, until its display shows the desired airbase identification number, for Creech it's 01. Next, Press the corresponding base selector button, for example press AG to communicate using Creech's UHF frequency, or press B to use VHF. Once you have the appropriate preset, close the kneeboard with right shift plus K. Just to check that the radio is properly tuned, we will contact ATC to request startup clearance. Press the key or button that you have binded to the FR22 push-to-talk, on my case it's right control plus P. The DCS communications menu should appear. Select F5, ATC. F1, Creech. F3, request startup.
Springfield, 1,
Press spacebar once
startup.
air traffic control gives you clearance to start, and press F12 to exit from the communications menu.
Cleared for startup. Wind 150 at 6 meters per second.
HUD slave switch, Slav SI. Check it set to off, F. For very low level flight, under 100 meters, this switch enables a decluttered HUD mode. Only the attitude reference line and flight path vector remain shown. The heading tape can still be displayed by pressing the reference button on the control stick. Altimeter source selector, HOD CISI. Set to LD, barometric. The altimeter source used by the Viggen computer can be toggled with this switch. The LD position uses barometric altitude, while RHM uses the radar altimeter as source. Backup altimeter, set to QFE value, atmospheric pressure at the airport. The backup instruments are operated from the pitot mounted on the tailfin, and thereby are separate from the main instruments and the flight data unit. Rotate the knob until the altitude reads 0, note that 0 is at the 6 o'clock position of the gauge. Press spacebar once set. Radar warning receiver and countermeasures pod, set as desired. We will study this whole subject in more detail on a dedicated training mission. For now just set the RWR knob to its light's position, visual warning only, audio muted. The Viggen doesn't have built-in countermeasures, instead it relies on an external pod, which contains both chaff and flares. Press spacebar to continue. Exterior lighting, set as desired. The navigation lights are mounted on the leading edge of each wing, red and green, plus 2 white lights mounted on the tailpipe assembly. They are controlled by the switch lantern, set to its bright position, HEL. Small white position lights are placed on the back of the wingtips and the outer elevon servos. Set to on, till. Their brightness is adjusted with the highlighted knob. Formation lights are mounted on the side of the fuselage. Additionally, a light is placed on top of either wing to illuminate the tail number. Set to on, till. 2 anti-collision beacon lights are mounted on the top and bottom on the fuselage, set to on, till. Weapon selector, set as needed for the mission. Rather than selecting a weapon pylon, like other aircrafts, on the Viggen this selector designates a weapon type. For this mission, set the knob to IRB, infrared missiles. For the Sidewinder missiles, you can use the highlighted knob to adjust the volume of its heat seeker audio tone. Turn it full down, as it can be a bit annoying. Weapon release mode, set as needed for the mission. This switch is used for anti-ship missiles, or rockets. It does not apply to our current weapons, so press spacebar to continue. Weapon targeting mode, as mission needs. This switch is used for the BK-90 and anti-ship missiles. Not needed for our current loadout, press spacebar to continue. Oxygen. Check pressure and open flow valve. The gauge indicates the remaining pressure in the aircraft oxygen bottle. A valve mounted next to the indicator regulates oxygen flow. Its upper position, till, opens the oxygen flow. Do it now. Canopy, close and check locked, may be closed earlier if needed. The canopy is operated by the canopy actuator handle, and it is sealed automatically if the canopy is closed and the engine is on. If the canopy is opened or not locked, the indicator light of STOL is lit on the right warning panel. The engine is started by a gas turbine starter unit, GTS. Essentially a small jet engine, it runs on the main fuel source. Once it reaches the correct RPM, the GTS clutches onto the engine, and accelerates it until it reaches self-sustaining RPM. The GTS does not provide any electric power on its own, and can only be started via the automatic startup sequence. The whole sequence is initiated via the start switch, or automatically in case of an in-flight start below a certain engine RPM, where the GTS is necessary. Engine start switch, set to on, till. On the real aircraft, the switch must be manually held at on for 2 seconds, before it is magnetically held by the starter, but this is not yet simulated on DCS. The engine start sequence is electrically controlled and operates automatically after pushing the start switch. The start sys caution illuminates when the GTS initiates its power-up, which takes a few seconds, then it will clutch to the jet engine, indicated by its RPM increase. At around 10% RPM, fuel enters the engine and the igniters are energized. The tan sys caution will illuminate at this point. The generator is now online, the red ELFL alert goes out. At this point the start switch goes off, the GTS is stopped, and the start sys and tan sys cautions will go out. The engine has reached ground idle. Check the following items: RPM, between 55 and 65%. Idle exhaust gas temperature, EGT, not more than 350 degrees Celsius. Engine pressure ratio, should stabilize around 1.0. Engine nozzle position should be fully open. SPAC stabilization, should have turned on automatically. Check its green light is illuminated. Warning panel lights. All lights should be out, except the following: OL jet rick. The oil pressure caution can be lit for a maximum of 60 seconds. X-tank bra, the drop tank fuel pressure illuminates, for as long as the engine RPM is below 70%, as the bleed air being produced is not enough. The 3 green stall lights for the landing gear will remain lit until takeoff. This completes the ground idle checks. Press spacebar to continue. Backup artificial horizon, uncage. Indicates aircraft orientation in pitch and roll by rotating a cylinder against a fixed symbol. Pitch is marked every 10 degrees. Roll is indicated by the moving index on the bottom. Click and hold its button until its fixed reference is aligned with the horizon. Press spacebar to continue. Fuel indicator, check. Its main needle indicates the remaining fuel volume in percentage. Should deviate a maximum of ±5%, from either 106 or 131%, full fuel load without, or with, an external tank. The striped needles indicate the currently needed amount of fuel to fulfill the planned flight as programmed into the computer. The required fuel is continuously calculated and displayed, as the amount of fuel required from the aircraft's current position to the next destination, and the remaining route to the primary landing site, L1, plus the amount of fuel required for a landing. The computer accounts for the increased drag, due to weapons and planned flight path and profile, taking into consideration the variables of ingress speeds and wind. In addition, a preset fuel reserve is added to this calculation. This preset amount can be set by the pilot to ensure a greater margin. Press spacebar to continue. Data input. Load the data cartridge onto the computer. Visually confirm that the data cartridge is inserted on the data cartridge slot. The data cartridge can only be loaded when the aircraft is on the ground, and loading the cartridge will automatically clear all previously entered mission data. Press spacebar to continue. To load the flight plan data from the cartridge, first turn the computer data selector knob to its Ref LOLA position. Ref LOLA means reference number or longitude-latitude. It is the computer mode used for navigation, where geographic coordinates are designated either as a longitude-latitude, or by reference number, for example an airbase known to the computer. Next, set the input-output data switch to in, as we will be entering a value. Good, now enter the code 9099, using the computer keypad. OK, the visor is showing 9099 and 00 for the last 2 digits. During the data transfer process, the leading 9 will blink. A failed transfer would be indicated by the first digit no longer blinking, but the display still showing 909900. Now, press the LSSKU button to start the data transfer process. Good, the transfer was successful, indicated by the visor changing to all zeros. Now set the input-output data switch back to UT, out. Set the data selector knob back to ACT POS, active position. On this mode, the visor displays our current position, the turn-nav status, and the estimated navigation error. We will study the computer functions in more depth on a future training mission. Press spacebar to continue. The next few check steps should be performed irrespective if the start was done with, or without, ground power. Control surfaces, check. Move the flight stick and rudder pedals to full deflection in all directions, to confirm their correct operation. Press spacebar to continue. Pitch trim, check and set. Set 4 degrees of nose-up trim, if the aircraft has no drop tank or the drop tank is empty. Set 5 degrees, for aircrafts with full external tank. Press spacebar once set. Air brakes, check. Cycle the air brakes, using either your HOTAs, or by press and hold the right Alt+B keys. The air brakes won't stay open when the landing gear is extended. This is normal behavior. On the air, the air brakes would stay open when you release the keys. On the right warning panel, the Luftbremse green light illuminates when the air brakes are extended. Press spacebar to continue. Master warning and warning panel lights. Check. Press spacebar to continue. Landing light. Set the switch to its taxi position, aft. This completes the after engine start checks. Press spacebar to finish. Very good. You have successfully completed this abbreviated cold start training mission. Press spacebar to exit from the mission.